No, nope. All right.
I'm with you.
Ladies and gentlemen, a round of applause for the one, the only Doug Hall.
Thank you. Raise your hand if you love data. I want to see hands. Yes. If anybody didn't raise your hands, you're in the wrong conference. We can provide coloring books at the back there, that's fine, but everybody's here to love data. Follow-up question. Hands up if you want more data. Yeah? Still some hands? Yeah, thought so. There's the problem we see. See, data collection is a big thing, okay? It's all about, I want to collect data. Notice I don't say capture data, we want to collect data. It's like being kids in a sweet shop, isn't it? You've got all this data, let's do some amazing stuff. But why isn't data use as big a thing? We're all about getting the data. Well, why is this? Well, so often data collection feels hard, okay? It's, oh my God, how do I get this button clicked to register as an event through GTM? And finally you get it, and you win. And it feels like a win. So you think, oh, thank God, we've got the data, we'll move on. But you shouldn't be satisfied. You cannot afford to be satisfied just collecting the data. Because any data collection has a cost. And if something costs you, costs your client, or costs your company, then you've got to treat it like an asset. You've got to get a return on this data. Now, to get a commercial return, to get the euros, the forints, the pounds, to get the data to deliver, okay, you've gone through the tactical collection, but the strategic value comes from usage. Usage is so key here. So this talk, originally, I gave this at Marketing Evolution Experience with 5 case studies on how I used data. This is version 2. This is 4 more case studies on how I use data. Now, I have to be absolutely honest here, I stand on the shoulders of giants. A lot of the work you're going to see here was inspired by clients. It was inspired and delivered by my colleagues and peers in the room. So if I fail to give credit where credit is due, call me out, but I do want to make sure you understand this is a lot of hard work by a lot of people. So I want to talk through control groups, smarter audiences, why relying on a single perspective is dumb, and how you can fix it, and don't waste time or effort on cycles. Okay, so let's start with control groups. So I had a client, and they wanted to do 2 things with their data, with their site. They wanted to demonstrate the incremental value of their test program, and they wanted to be able to deploy personalization treatments incrementally. Okay, so this was a gambling company. So they had a new bet slip, and the bet slip is the fundamental hub of the functionality of the site. So you're rolling out a new bet slip, they want to be able to roll that out incrementally to be controlled, to control the deployment of this functionality. Okay, so how do we do this? Well, should be easy, right? You go into optimize, you spin up a treatment, you go 90% control, 10% on the treatment, and everything's happy, right? But next, you want to increase that incrementality, you want to go to 20% deployment. You want to be able to show new functionality to 20% of your audience base. Now here's the problem, right? Let's say we're doing a 10%, 90% split. So everybody in front of me here, you're representing 10% of my user base. Stand up, stand up, stand up. I'm not kidding, get on your feet. There's our 10%, okay? All well and good. And you guys get to see my new functionality. We say, okay, now let's go to 20%, right? So sit down. Thank you. Very good. Very good. So, yeah, well, applause if you want. But here's the problem. Then we go to 80%, 20%. The thing is, you're now, stand up, you're 10%. You lot, stand up. You're the other 10%. Where the hell have you guys gone? It's a completely random distribution. 10% buckets, they change on each test deployment. Okay, thank you. Sit down. Round of applause. Well done. Applaud people for standing up. I mean, come on, it's a good thing. You're playing along nicely. So that doesn't work. That doesn't work. So consistent 10% buckets is a thing. This is very, very important. So to do the incrementality, and this is the first call out, I read a very good article by Matt Gershoff on Conductrix around, yes, worthy for sure. What's the value of my A/B testing program? And he proposed a really cool technique where you run a series of tests in a test program. and you make sure that 10% of your users are never tested, okay? So then all the other 90%, at the end of your test program, you can compare their performance with the 10% who weren't tested, and that will tell you whether or not your test program overall has delivered value, okay? So that's where we need a consistent, reliable 10% bucket. And if we've got a reliable 10% bucket, then we can start to add those to our incremental functionality rollout. Happy days. This is all good. So not a nice bucket challenge. Doug's bucket challenge is to create these random buckets, but consistent, reliable random buckets. When I say random, I want to make sure we've got a roughly equal split of desktop, mobile, want customers, not customers, that sort of thing. So it's got to be an even distribution, consistent and reliable. How are we doing this? Okay. First technique, there's two ways of doing this that I've explored, okay? So the first thing is you can manufacture your data. If we take the last digit of a random number, Aurelie, give me a random number, please, of 4-digit length. 7,436. The last digit there is 6. Give me a random number of 4-digit length.
1,234.
1,234. 4 is the last digit. So you're in bucket 4, you're in bucket 6. See how this works? Okay. So then a little bit of GTM. We can save this as a cookie, and we, over time, put people into our buckets from 0 to 9. Happy days. One way of doing it. But you've already got this data if you're running GA, because your users will be assigned a client ID. And if we take the mod 10 and plus 1, divide by 10, take the remainder, that's also going to give us a number between 1 and 10. There's our 10% buckets, already manufactured. This is pretty handy. This is cool. So we can set the bucket at the same time as we set the client ID using custom task in GTM, all well and good. So we can set our bucket. So I've been running these two techniques on ConversionWorks.co.uk since September. Well, we know Amazon, so we don't have massive volume coming to our site. People read our blog, that's fine. So we've got relatively small data, but actually, this already still looks pretty good. So we can see our different buckets there. Span this up on the 18th of Jan. It's roughly about right. That was the random number. Client ID, that started later, so the volume is less. A little bit of variance there, but it's coming together. It's getting good. Now, hopefully you're getting the idea by now, but one thing to consider, or a few things to consider, is 10% the right thing for your business? You may be thinking more granularly. 5% buckets? That's fine. You might want to split it. I want 10% mobile, 10% desktop. Fine, you can split it like that. 10% customers, 10% non-customers. You can split it anyhow you want. That's absolutely fine. Okay, we're going to stick with a 10% for illustration for now. And the important thing is, once we've collected this data, then we build our segment. So we've got our client ID bucket, exactly matches 1. It's giving us 9.91% of our users. That's about 10%. That's good enough. Then we rinse and repeat. So I've got 10 buckets, all of about 10% users. Once the bucket number is set, it ain't going to change. So these are consistent, nice, evenly distributed over time. This is good. Segments turn into audiences. Audiences we use for targeting in Google Ads, Optimize 360, and for analysis in Google Analytics. Great stuff, okay? So here's a takeaway on how your 10% buckets can be of use, okay? Actually, it's data you've already got, and if you're not using it, you're guilty. So you should start using this. It is way better on larger volume sites. Even on a small site, as we've seen, it's going to be valuable over time, and you want to consider which buckets you want to employ. Handy stuff. Okay. So I mentioned audiences already. Hopefully you're all using segments and audiences, and this is how to do it better, much smarter. Okay. So I had a client, they're arriving today actually, Dr. Wenting. She's one of my favorite clients. She has this great idea. She wants to be able to personalize a market by user interest, but not using some targeting algorithm defined by some chief marketing hippo. No, we want the existing user data to be able to tell us what our users are actually interested in, and can we build audiences based on intent, based on interest. Now they've got a very broad range of content across their sites. So we've got a vast amount of data, which is great, it's very rich. So can we use some unsupervised learning to discover these buckets of intent and interest? Sure can. We would use segments, right? Dead easy. You're all using segments, I hope. If you don't have segments, you're lacking context. You do need to employ segments to get better answers. We know this. And then from segments, we generate our audiences, which are super powerful for targeting, analysis and reporting, paid media, personalization. You know this. This is all fine. This is all good. But, here's the but. There's always a but. Audiences are flawed, okay? Think about how you go about building segments. Typically, you're going to be thinking a couple of metrics, a couple of dimensions. There's our segment. Happy days. All very good, right? But what about this context where we're thinking about 200 custom dimensions? We're talking about 200 custom metrics, all from GA. And we're introducing a data from the CRM system. We're talking about a massive dimension space. This starts to get really, really hard. We can visualize a two-dimensional space, maybe even a three-dimensional space. Four-dimensional space, I'm going to start to get RSI. 100 dimensions, can't even begin to imagine what that looks like. Visualization is one thing, but understanding it and saying, well, which of these dimensions really matter? That's a bigger problem, to understand which ones are right, which ones are best, which dimensions or which variables are the most important ones to use. We don't know this, we're guessing. It's often the case, okay? It's a big question. How do we use our variables? So many variables. We end up with a paradox of choice. It's, yes, we're in a sweet shop, I just can't choose which ones to use. This is difficult. It's difficult when we're talking about lots of components, so I'm going to introduce you to the idea of principal component analysis and k-means clustering. Some of this you may know. Well, this was new to me. So k-means clustering, unsupervised learning to group data points, in this case, users, okay? So that's k-means. Let's reiterate here. Let's just remind ourselves we're talking about a large dimensional space, hundreds of dimensions, hundreds of variables. So if we were to do k-means clustering on a few hundred dimensions, then this is computationally pretty exhausting. This is going to be expensive. And once we've done our clustering, it's going to be hard to visualize, hard to analyze. It's not great. We need to reduce our dimension space somehow. And this is where principal component analysis comes in. So we're reducing our dimension space using a linear transformation. What? Okay, right. So on the left-hand side for you, yep, we've got a graph of 2 dimensions, and we've plotted our 2 dimensions. On the right-hand side, we've done our linear transformation. We've drawn a line there that describes most of the data, okay? What we've done there is put together, in broad terms, a correlation matrix. We know as one dimension value varies, we can see how the other dimension value varies, okay? So we've got this covariance matrix that tells us how 2 dimensions correlate. So let's repeat that. Let's rinse and repeat for n dimensions, okay? So then very simply, we take our eigendecomposition of our covariance matrices, delivering our eigenvalues. From that, we can derive our principal components, right? Yeah? Oh, wow. It's too early, isn't it? It's the keynote. This is way heavy stuff. This is way heavy stuff. That's the face I made when I first read about this. I was like, wow, lots of big words. Sounds good. Cracks the ice at dinner parties. Not well. That's easier. Okay, Danny, what's that?
It's an apple.
It's an apple. No round of applause necessary. Sorry. What does it taste like? What does it taste like?
Acid? An apple?
An apple. This is an apple, and it tastes like an apple. One dimension. You've got it nailed. That's applause. The apple. More complex, though. This is a chicken tikka terrine with sweet pickled carrot, smoked garlic, yogurt, and beans kachumba. How does that taste? Bloody lovely, I tell you. That pickled carrot was a sensation. It was gorgeous. But to be able to decide what are the ingredients that dictate how the overall flavor of the dish feels, what does it taste like? Because it's such a complex and sophisticated palate involved in this, it's really hard to say, tastes like it. You can't do that. So we combine all of our different ingredients together that tells us in one nugget of information how the taste of this dish is. To say it's bloody gorgeous isn't strictly useful, but you get the idea. This is principal component analysis compared to a smaller dimension space, okay? So, a more concrete example. Any R users in the room? Yeah, a few. So you'll probably know with R you get sample data sets. This one is empty cars. This is sample data around a whole bunch of different cars from an American car magazine in the 1970s, okay? And we've got a set of dimensions, variables here that are derived from the car. So we've got the number of cylinders for each car, number of carburetors, miles per gallon. So we've got a bunch of numbers that describe each car. And if we run a principal component analysis, one line of R, dead easy, run a PCA on empty cars, we get the graph on the right. So we've got two principal components. On the X, PC1, on Y, PC2, and you can see each point is a car, and we can see how on the right-hand side, with a high displacement, high number of cylinders, large number of carburetors, high weight, we've got powerful cars described over here. So with one principal component, we've taken all of these dimensions to describe that type of data. On the left-hand side, we've got low miles to the gallon, low quarter-second time, and we've got our light and efficient cars. So you can see with 2 dimensions, we've still got all of our variables in our problem space here, where we can more easily describe it, more easily visualize and understand the data at hand, okay? So this leads in nicely to the k-means clustering, K being the number of clusters. How do we decide how many clusters or how many globs of users we might be interested in, okay? We don't want to guess again. So we've got two methods that we can use here. There are many more. We can use the elbow method or the 85% variance, okay? So 85% variance, this is the empty cars, each bar representing the degree of variance in each principal component. By variance, I mean how much information does it actually contain? So we've got the first 2 principal components, so I'll just flip back. It's maybe a bit small. We've got 62.8% of variance explained in PC1, 23.1 explained on PC2, so it's 85.9% of the variance is explained by just 2 dimensions. So that's most of the information in our data set captured in just 2 dimensions, 2 clusters therefore. Different set of data. See how this looks like an arm? Yeah, look at the gun. We've got 1, 2, 3 principal components, and as we go beyond 3, we're not explaining that much more variance on each step, so we'll just choose 3 principal components to describe our data to get 3 clusters. That's all we need. Far easier to describe. So we're clustering on 3 principal components. So this is giving us a much smarter choice of our clusters. Okay, how do we actually use this? So a bit of data science there, the actual application. So remember, we're considering all of our variables in GA, and we're introducing CRM data as well. So we've got large dimension space, okay? All the variables are still being used. We perform the linear transformation, and that means then we can feed it into the k-means clustering, cluster our users, define our segments based on our principal components, get better audience definition, and do smarter targeting. This looks really interesting. This is actual data that we got. So we've got a nice elbow there, over the left-hand side. 3 principal components. We've actually gone for 10 to explain 85% of the variance of our real data. And we can start to visualize how these clusters fit together as users based on our components. That's all well and good, looks flashy, but this is the secret sauce. This is the magic. So we can see our cluster over here. We've got users who are really interested in cars, specifically Audis. They're like bathrooms, they're into kettles, TVs, but they're desperately not into banking, baby transport, laundry, or computing. So we can start to see where the interest is for that particular group of users. We've got people who are big into broadband, but desperately not into laundry or cooking. You might be into cleaning big time, but you're not into investing. So knowing what turns people on, as well as what turns people off, this is pretty powerful stuff. This is what intent-based marketing and personalization needs. And this isn't based on a hippo whim. This isn't based on a C-level's idea of, I want to make these users do this. This is the users having told us this already. So we can take from that, we need to know more stats, okay? We don't need to go to degree level, but it's certainly a worthwhile education. So we can solve for high dimensionality. We can define audiences better. And here's a really key point. You can expect your clusters to vary over time. With seasonality, intent is going to change. So this exercise is something you would repeat throughout the year, quarterly. Okay. The danger of relying on a single perspective, okay? Look at this. I got like 136 million page views on my content. That's delighting. Yeah, really great. Lots of views on data. But, all right, that's just page views. It's just a total. It's just one number. That doesn't tell us an awful lot. It doesn't tell us about per user metrics. It doesn't tell us about the median values in terms of content consumption. It doesn't tell us about any sort of outliers. It's just the total. Not great. So we've got to remember, not all content is equal, not all metrics are equal, and that the distribution of the data is highly, highly informative. Okay? Let's talk about distributions. Let's talk about height. Okay? Height varies. Yeah? The quintessential and the MC. Height varies by gender. Okay? So we can see there is a distribution in terms of height. I'm 6'7", and that is a number. But as far as me fitting on the distribution, you might think I'm an outlier. That's very kind. Okay. Sessions-wise, that's a day of sessions. Great number, right? Lots of sessions. But sessions over the whole day, that distribution tells a different story. That's much more useful than just one number. Like that a lot. Okay. So diving straight into the box plot visualization of our page views per user distribution. Okay. It's hard to read there, so I'm going to drill in for some more clarity. But you can see there's a bunch of different box plots, and we've got product category as a content group on the left-hand side. Let's take two cases here, okay? So we've got broadband deals, very tight box plot. There's our median value as the spot, and our distribution expressed as a box plot. Televisions, much bigger box plot, a lot more variance there. Very different distributions. From this, we can infer a lot more than we can just looking at a number that says how many page views. So if someone is looking for a broadband deal, we may infer that the user knows a lot more about what they want. They're a lot more focused. This is the deal that they're looking for. But TVs, what's your most expensive TV? Have you got an 8K TV? You know, these are the casual questions that we will find in the outliers, much more different to the median value. So understanding that these distributions are very, very different helps us better understand how this content is being consumed, okay? So knowing that high page views does not necessarily relate to high interest and engagement. It does help us understand there is a different question or a different intent the user is trying to solve for. So we can engage differently depending on how we can observe the user's behavior. If we've got a low number of page views per user, this user is more casual, as opposed to someone who is looking for that deal and they want that deal now. So we can personalize and we can tune according to that opportunity. But you may choose to ask the question, is my opportunity on my site with the median value, or is it with the outlier? Do I have the larger volume, the larger opportunity, looking at the median value users, or should I look at outliers? Okay, and you will deliver the content and the functionality to align the site better with the engagement pattern. Can't do that with just a total. So, one metric is giving you a very limited view. You do need to explore distributions, find your mean values, your outliers, and understand and decide how you're going to use those appropriately. Okay. Final case study, pre-processing your data. Okay. So we at ConversionWorks, we use BigQuery for our clients an awful lot. You probably do as well. Probably running some pretty hefty queries, yeah? So you're getting lots of data processed, you've got lots of data to return. And if we're using R with a Shiny app, I tend to see this a lot, and I hate this. I hate the spinners. I hate waiting for the data to arrive. It's frustrating. So the client wants us to pre-process the data. They don't want to wait either. They want to get the machine to do the work overnight when the data arrives. So we're going to do batching here, okay? Bunch of ways of doing this. A few different ways of doing this. We're using Cloud Scheduler an awful lot. So what I've got here is a Cloud Scheduler job that I use to spin up and turn off our compute engine virtual machine on our work hours. Okay, so 7 o'clock, I'm there. 7 o'clock, I'm not there. In between, I can use it. Okay? So spinning up a VM, that's handy. But not only can I spin up the VM, I can have a startup script as part of that VM spin-up process that's going to start processing my data. So there's a couple of steps there. Decide when the VM needs to start, when it's going to start processing the data, and we can schedule this. No software written, dead easy stuff. Or, if we've got a VM that's on all the time, we can take our R script, wrap it with a package called Plumber, which turns an R script basically into an API. So we can say, on Cloud Scheduler, pushing a message into PubSub, we can fire a Cloud function that will start processing our data. We've got control when our data is being processed. That's a good start, okay? So we can also, if our data is arriving in Google Cloud Storage, as a file is dropped, we can use that to kick off a Cloud function that starts a VM that processes our data in the Cloud Storage bucket, yeah? So we've got a couple of triggers there that let us start batching our data. So the file drops, we process it. But the thing is, this doesn't solve for the BigQuery question. BigQuery, if we're using GA data, at some point, when the big G decides, the data drops from GA into BigQuery, and that's when we would like to start processing it. How do we know? There's no file being dropped there. Well, we can use a query that says, do we have yesterday's data yet? Do we have yesterday's data? Do we have yesterday's data? So we use BQ to schedule that query to start asking that question from 4 in the morning, and as soon as the query doesn't fail, then we send a message into Cloud PubSub, which kicks off a Cloud function, which starts a virtual machine, which processes our data. Yeah? That's all well, yeah, it's pretty good. But, I said there's always a but, as I was writing this, I noticed this really smart guy called Mark Edmondson wrote an even better solution. So I thought, wow, okay, I stand on the shoulders of giants, I have to include this. So what Mark says, what Mark identified was, when GA has finished processing its data and it drops it into BQ, all the cloud products use Stackdriver for their logging. So there is a log in Stackdriver for when GA has dropped its data into BigQuery. So from our filters there that identify our GA into BQ event, we can then create an export. The export then drops a message into Cloud PubSub, you know the rest, which kicks off an R script or Python and starts processing the data. So there's a lot less that we have to do in order to recognize when our data is there and when we can start processing it. Why? What's all this good for? We're removing a shed load of latency. It's all disappearing, okay? Even more importantly, we don't have to repeat the computation. If we're doing the same processing for a report every single time, that's going to get expensive. It's wasteful. We don't have to wait. I want to get the data. I want to get the data now. And this is a really great exercise in learning how to lean on the cloud functionality that can do stuff so we don't have to write our own software. The tool's are already there. The components to allow us to do this, ready to rock and roll. So takeaways from here, number one, read Mark's blog. That's one I do regularly. I thoroughly recommend Mark's blog. Learn about cloud functions, PubSub, Stackdriver, Cloud Scheduler, and scheduled BigQuery queries. Super, super powerful tools there. Okay, thank you.
Applause for the one, the only Doug Hall.